Infrastructure fundamentally is what I call the engine behind the growth of this company. We have been building data centers since 2010. We're talking about serving maybe a half of humanity. Now when we're talking about AI, you need a similar engine behind AI so that AI can achieve the potential that we are sort of dreaming.
AI workloads are growing at a pace of 1,000x every 2 years. I mean, just contemplating what that means for our systems, our silicon, our software stack, we're in the middle of a pivot to the next age of information.
The models themselves are becoming hundreds or thousands of times larger and more complex. And what this is going to require is infrastructure at the exaflop level.
We're reimagining everything we do about our infrastructure for AI. We're creating data centers that are specific for AI. We're creating new hardware, including our own silicon. We're building out new kinds of network architectures. We're reimagining the software stack like PyTorch. Thousands of engineers are innovating on this large-scale infrastructure that's built specifically for AI.
Meta Training and Inference Accelerator. It's Meta's first in-house silicon. It was designed solely for recommendation models in mind, and it is a piece that fits with the rest of the system like software ecosystem for writing applications and deploying ML models. And it's built in-house.
By having it in-house, we are able to optimize every single nanometer of the chip. So we don't have any part of the architecture that is wasted. And that helps to bring down the power.
The fundamental target in designing this MTIA is to provide highest performance in the lowest power. And in the process, we achieved twice the efficiencies compared to today's GPUs.
Another silicon product built by Meta is MSVP, Meta Scalable Video Processor. People spend more and more time producing videos and sharing videos. That means more and more pixels will hit our data centers.
MSVP processes these videos 9 times faster than the traditional software encoders, maintaining the same video quality at par with the software encoders and at half the energy.
MSVP can be the final engine that takes all the generative AI content that people create, eventually needs to be encoded. It can never traverse the internet in its raw format. All these requirements put together necessitated the design and manufacturing of MSVP.
So our new silicon hardware is going to need a new home. We're working on the next generation data center design. The move into sort of AI machines is going to leverage GPUs or custom silicon that we're developing ourselves, and that's going to require a more dense data center design. We're going to be leveraging higher dense racks. The servers themselves will be liquid cooled to the chip. And with flexibility in mind, we're going to collate servers and network together to enable future generations of AI.
We believe our research supercluster is one of the fastest AI supercomputers in the world. It is one of the unique places where you can run truly large-scale jobs. We have 16,000 GPUs interconnected with 1.6 terabits per second of InfiniBand network, producing approximately 5 exaflops of compute power. We also have almost half an exabyte of storage backing the compute plus network. The advancements in AI are coming at the right time so that RSC can be put to use to take advantage of the infrastructure and the data and then move fast.
We design, create, run, and operate all of our infrastructure. So it's a sweet spot of being able to work at scale, work at cutting edge, and also do work that literally hits billions.
Infrastructure at scale is what our long-term research requires, and innovation without it is impossible.
I feel like I'm in the middle of a revolution.